So class, now I'm recording. Just a disclaimer, and I'll be sharing my screen shortly.
Yo, Linus, did you share the slides with us?
Give me a second. Actually, yes. So can you see my screen? I'll come to the screen later, but can you see?
Yeah, we can see it.
So today, we're going to go through AWS. Obviously, it'll be AWS Fundamentals. Like I mentioned before, AWS is a different base, you know, it's a different class on its own. It's not me saying that it's complicated, it's not. It's just so many, you know, there's just a huge learning curve. So if you want to know everything, but good thing for us, we don't want to know everything. I work as a DevOps engineer, and I don't use 40% of what Amazon offers, you know. I'm only using about 30% to 40% of what they offer to do my job. My job's pretty much. So it's not something that you want to know all. If you want to be like a cloud architect or AWS cloud architect, you might want to know a little bit more of everything. But as a DevOps engineer, you know, you want to know, how can I go into AWS? How can I spin up servers if I wanted to? How can I build pipelines through AWS? How can I, you know, just understand, you know, the fundamentals and the networking. I don't know if we're going to go through the actual networking part of it today, but that's a little bit complex. Not difficult, just different from what we're going to talk about today. So we'll probably take the networking for Thursday when everyone's a little bit more familiar with AWS and how it works. So anyways, I'm going to start, you know, just with a basic slide. So what is cloud computing essentially? You know, these slides I'm going to clean up, you know, but you know, cloud computing essentially is a company that just actually provides different services, right, via the internet, you know, different cloud services, if you will. And some of those cloud services, especially for AWS or any other cloud. So now, the beginning of the class, the first few slides, I don't want us to talk about AWS. I want us to talk about cloud computing as a whole. Because, you know, they're all the same concepts. AWS might be the biggest right now, but they're all the same concepts. So anybody that does provide some kind of services via the internet, you can call them a cloud service, right? So, you know, it brings this, you know, you can start thinking about, okay, well, what else is a cloud service, right? Most of those, possibly most of those shopping websites you shop on, you can still call those cloud services, right? Because it provides you some kind of service that without you having to worry about infrastructure or anything. But when we talk about cloud computing, we'll talk about the cloud providers. And they'll provide you something like, you know, that data storage. They'll provide you with servers, databases, networking, and software, many other things. So this is what the cloud provider will provide you. So back in the day or before, when you have to run a system, you have to go to the store, you have to buy a server, you have to buy a rack, you have to buy networking tools, you have to buy routing cables and all that stuff. And you have to build your own, what we call a data center. So essentially, you're building everything that the cloud is providing with you, but you have to buy those things and you have to be an expert, right? Because building a server, you could build a server, or you can go buy a server from, let's say, Best Buy, and you build it, but you need something called a hypervisor. And what the hypervisor will do is be able to separate those servers into different VMs, which is what the cloud provider is doing for you. You know, you could do networking. You're going to need networking cables. You're going to need probably a networking guy. So imagine that, building an actual server, you have to hire a networking guy, an infrastructure guy, and all kinds of stuff, you know. But now with the cloud, you don't have to do all that. I could just rent all that stuff, right? Someone already created them. So that's why cloud is so important. So most cloud services, they work, you know, in many forms. One of them, as you can see here, is going to be infrastructure as a code. As you can tell, infrastructure as a code is essentially, I'm a cloud provider. I'll provide you your VMs. I'll provide you your storage. I'll provide you your networking, right? Most of the things that you normally buy to create a physical data center. they'll provide that to you. And all you have to do is just build your infrastructure on top of that. And when we talk about that, that's what we're talking about, EC2s, which we're going to talk about today. We also have platform as a service. So platform as a service, essentially, what they're giving you is a whole platform, including your deployments and all that stuff. So for example, another easy example I'll give is with AWS, you have something called Elastic Beanstalk, right? I have my Docker image or any program. I could just run that on my Elastic Beanstalk without worrying about deployments, without worrying about the actual infrastructure that is running on or anything. So AWS Elastic Beanstalk, which I'll show you later, is one of those platforms as a service. I know you've heard about the Google App Engine. I don't know if anybody heard about that. That's a platform as a service.
What's that again? Repeat that.
The Google App Engine, application engine. That's a platform as a service. That's for GCP. And, I know you've heard about Heroku. I don't know if anybody has heard about Heroku. Those are all platforms as a service, because with Heroku, you're just running your app. You don't worry about the infrastructure and all that stuff. So that's what the platform, and we have function as a service. So we're going to talk about this briefly. Function as a service, essentially, you don't have to worry about pretty much anything. I'm just bringing my code, right? I have my Python code, my Java code. I just run it on your runtime. And all I'm paying for is for the time that I use and the compute power that I'm using, pretty much, right? So that's a whole different level. And when you talk about AWS, you have something called Lambda functions, which you're going to briefly go through. Lambda function essentially function as a service. I write my Python code. I don't care where that Python code stays, because all I'm going to charge for is the hours or the time that I use to run that Python code. I'm not getting charged for infrastructure. I'm not getting charged for RAM and CPU. So that's what we call function as a service. And another example, I've used the Lambda functions to do automations, right? So what I'll use is something we call event bridge, which I'm going to talk about. And they automatically trigger my Lambda functions. And my Lambda functions do work for me, right? I just have functions that are automatically triggered. You could trigger them using SNS topic. You could trigger them using something what we call API gateways. So those are things that we might get into on a brief. And I'm gonna just show you how a Lambda function works.
Wait, can I clarify? So they basically rent from them, right? Like they pay a subscription or some sort of service?
Well, no, but for AWS, it's not a subscription service. So you only pay for what you use.
Right. So if I come with the code, I can only run that temporarily as long as I pay, right?
You can let that code run whenever you want, but just know that if your code takes 10 seconds or 20 seconds to run, you're going to be charged for that 20 seconds. And if it runs again for another 20 seconds, you're going to be charged for that 20 seconds.
Gotcha, okay.
Pretty much. So it's a different level. I can't tell you how much I've used Lambda functions to do automated tasks, Python codes that I have running on Lambda. So that's something to keep an eye on. Function as a service, one of them is Lambda function. Just keep an eye on, do a little research on it, because it could change your game, because I think it's the future, This is definitely, I wrote a white paper on this, I think a year ago. that was 2 years ago. I wrote a white paper on Lambda functions, because I was projecting that it was going to be big. And I think now it's even bigger than when I projected it. So that's something I'm a big fan of. Like I said, I went as far as writing a white paper for it. So it's something to keep an eye on. And then we have software as a service. This one is for on-demand service, right? So I'll give an example of what is software as a service. Gmail is a software as a service. We just use the email, but Gmail takes care of the infrastructure. They take care of the application, deployments, upgrades, and all that, right? So that's an example as a software as a service. And AWS, they have other kinds of software as a service that will provide to you right now. You just consume pretty much, and you don't have to worry about whatever software I'm consuming. So Gmail is one of those software as a service. So cloud providers, and then we have finally container as a service. So when we talk about container as a service, we're talking about ECS, Kubernetes, right? So now a company like Google has the Google Kubernetes platform. AWS has something we call EKS, Elastic Kubernetes Platform. They also have ECS called Elastic Container Service. Those are all containers as a service. So essentially they provide you those containers, you just run your application on them, pretty much. So that's container as a service. So that's just a runtime. Some of these videos, you have to go back and watch just to be familiar. But these are all services. So this was a diagram that I thought would help understand. So we see infrastructure as a service. It only consists of servers and storage, networking capabilities, firewalls, and the data center physical, right? That's just infrastructure. And then platform as a service contains infrastructure as a service, But then now you have your operating system like Linux, Microsoft, and any operating system that you want. And we also have development tools. We have RDS, like database management system. We have business analytics, like Redshift on AWS. So that's platform as a service. And then software as a service, as you can see, is the entire software, including the one we're using, like Gmail. As you can tell, Gmail constitutes a data center, a networking, servers and storage, operating system, development tools, and also the hosted application, which are Gmail. So that's what software as a service. So this picture kind of encapsulates like what the different categories is. And I promise you should keep an eye on this, because when you start working in AWS, in your mind, you should be able to tell which one is an infrastructure as a service, which one is a platform as a service, and which one is a SaaS. And like when I say platform, I know we had a DBA here, database administrator. Right now, as a DBA, I don't have to worry about, I'm not a DBA, but you don't have to worry about databases right now, because AWS offers platform as a service called RDS, or Relational Database Systems. So now you don't have to manage the database and all that stuff. You just have to make sure your database, they'll make sure your database is up. They'll make sure your database runs. If there's a failure, they're going to do a fallback and things like that. So that's platform as a service. So things are changing, guys. So soon, DBAs will be out of a job. That's why I keep telling you, DevOps is where it's at, because we run everything. I run everything, including databases. But then now you're seeing that they're starting to create that platform as a service. Oracle has a cloud system now. So Oracle can now manage your database for you. AWS does it, Azure does it. So that's kind of where we're headed. That's why I keep saying, if you're trying to be DBA, you're in the wrong time. You want to be looking forward, because all those jobs are going to be automated. They're already being automated right now with cloud. So these are some few cloud providers. You got to take this with a grain of salt, because there's so many. For example, we have Amazon Web Services, our number one. We have Microsoft Azure. We have Google Cloud Platform, which is GCP. I love GCP because of the Kubernetes service, right? It's excellent. Microsoft Azure, I love the DevOps. They have a good DevOps streamline pipeline. But Amazon Web Services, what it is, man, is a boss. If you want to do something, you want to learn from the biggest platform. The biggest platform will be the most paid, will be the most in demand, and will be the most, looked after. So, and then we have Heroku. And we also have IBM Cloud and some other cloud systems. So that's just to keep in mind that there's so many competition. So now, I guess why AWS? My diagram is not very evident, but you don't need glasses to see that AWS is top, over 35%. You have Azure climbing, Microsoft Azure climbing, but they're still barely hitting 20%. And right now, I can guarantee that AWS is approaching somewhere around 35, 36, even 40. You have Google Cloud Platform, GCP is right here. You have Alibaba, and this is one more, Alibaba. I know a lot of people heard about Alibaba, but Alibaba is a whole company on its own. It's not just a shopping website, which people are used to. Alibaba also had a cloud platform. And let me tell you, this one thing I'll tell you for sure is Alibaba is probably bigger than Google and Microsoft. The reason why they're not in that bracket is because they're mostly in Asia. But think about it. Alibaba has a market in Asia, that is China, Korea, and all those East Africans. They have more population than most countries. So one of the underrated cloud performers is Alibaba. I think Alibaba has way more cloud than is given credit for, because they're covering the entire Asia region, right? So just keep in mind, but they're all cloud platforms. So you can see why AWS is number one. They have been very stable, and I think they're going to keep going up as long as they keep, maintaining their products. So that's why we study AWS. All the companies I work for, they've used mostly AWS. Some have used Microsoft Azure, and I've done some work with GCP. But most companies are using Amazon. But if you are adventurous and you want to diversify as a DevOps engineer, when this class is done, you can go in and study Microsoft Azure, right? The mindset I want you to have is you should take the road less traveled, right? Right now, AWS is the number one stop. You'll be fine doing AWS. But if you wanted to even be more, more adventurous, you can go and do Azure and do your DevOps on Azure as opposed to AWS. Because remember, these cloud platforms, they all provide similar stuff. They all provide servers, they all provide Kubernetes, they all provide Docker, they all provide networking. They all do that stuff. So that's just something to keep in mind. So now let's talk about a little bit about AWS. So with AWS, the way AWS is set up is AWS is set up into regions, right? So you have regions. So you have your California region, right? You have your Oregon region. You have West Virginia. And I'm going to show graphics here very soon. I just wanted to explain the concept. So a region is a physical location which has a bunch clustered data centers. And then in those data centers, each data center will be in what we call availability zones, right? So for example, we have a region in Virginia. In Virginia, we have a region in Ohio. Virginia is the biggest region, serves the most, products. But then in Virginia, we have what we call, because the code for Virginia is US East, right? US East is Virginia, that's the Virginia region. But in that Virginia region, you have US East 1, you have US East 2, you have US East 3, even you have US East 1A, 1B, 1C, and 1D. And what those are availability zones. So essentially, if AZ1 goes down, you still have AZ2, right? You have AZ3 and AZ4. If AZ4 go down, so we're calling them availability zones because they're there to create high availability. So when the application goes down, you still have more running, right? So you're never out. If you want to be more adventurous, you can even spread your application by regions. So I can have one of my applications running in the California region while I have another application running in Virginia. Now you're set because you're not just located in 2 regions across, you're located in multiple availability zones across multiple regions. So that's the highest availability accomplishment that you can have. Like right now, I have some applications that I'm running. Those workloads it's a commerce company, right? So I have some workloads now that are meant to be for European, like for UK, France, and some few other European countries. I'm running those in EU region. So which is includes France, Germany. There's one in Germany. So I'm running applications in Germany because why? If you have customers coming from Germany, you want to run your application in Germany to reduce latency, right? As a DevOps engineer, that's part of your design plan. You want to reduce latency and you want to be able to increase the flexibility for your edge locations to be more effective. So we'll talk about that. Don't worry about that. But just to keep in mind, if you have an application, you have customers coming from Europe, you're better running your EU side in Europe, in the availability zone in Europe. So anyway, anybody have any questions about regions? Because I have something here that can easily show. Where is it? Okay, so here. So as you can see my screen, this is the US. So this is the California region in North America. We have availability zones in California. We have some in Portland, right? Those are 2 regions. And here we have, as you can see, the regions are the yellow. The edge locations are the green. So we have 1, 2, 3 regions. So I promise you one of them is Portland, Oregon area. One of them is California. And then there's one more region. I'm not sure where that is, but let's see if it says here. And then in the East, we have 3. We have Ohio, we have Virginia, and we should have one more region. They keep launching these regions. So you want to keep up to date because these regions, they keep launching them. For example, last year, they didn't have one in Africa, but now I think they have one in South Africa. So we'll go through. So as you can see, we have US West region in Oregon. It has 4 availability zones. So you can launch applications across 4 zones, data centers. You have California region, 3, and then you have Canada region. And then for the East, we have US East, Ohio with 3 availability zones. You have US East. So government cloud. Keep in mind, there's also government cloud. So this is only for government applications. So you as an individual company, you're not going to use the government cloud. This is for classified information. So you would never see government cloud. And you have US East Virginia, which I told you is the biggest. You see, it has 6 availability zones. We go to South America. We see there's one region, but there's multiple data centers across South America. We have one region here. I think this is Brazil area. And then you have regions across. We go to Europe. As you can see, we have 4 regions. We have Frankfurt, we have London, and we have a few others. And then we have one here in Mumbai, India. We have a region in India. And we just recently seen a region here in South Africa. So you could run your application in any of these regions. I could run if I have an application that I'm serving Africans, I will run my application here in South Africa. Because that will reduce my latency. And then we have Asia, which, like I said, there's multiple, Asians and IT. They love IT. So as you can see, There's China, there's Mumbai, there's Bangalore, there's Australia, and there's Indonesia and stuff like that. So just keep that in mind. When you go to interviews, they might, I've had interviews where they've asked me about, availability zones or regions. So I'll post this here in the slide. I'll add those in the slide. So anyway, that's what availability zones are. As you can see from here, this is a bigger diagram, just shows you. Yeah.
Can you just post the link to that page?
Oh, let's see. Give me a second.
Yeah.
Yeah, I'll try. I'll add that to the.
It's good that you just add resources like links sometimes, because then we can go in there and read up.
Yeah, I am adding them actually. Yeah. Yeah, I'm adding them to the slides, and before I upload the slides, I'll add more links in case you wanted more information. But any question about data centers, AWS, and all that stuff? So it's quiet now. So are you telling me that you understand what the regions are, the availability zones, and how they're set up, right?
Yes.
Because that's extremely important. That's important when you start designing applications. When you start designing VPCs and subnets, you want to know how your availability is being set up, right? You want to know, you don't want to run two database systems in one availability zone, especially when you have a database and replica. You want your replica to be in a different availability zone. So if your database goes down, it's automatically replicated in another region, pretty much. So essentially, that's why you keep that in mind. Anyways, this is AWS. So founded in 2006.
Real quick.
Yep.
When databases go down, for example, do they all tend to go down for example, the areas that have more than one database pretty close, will they all go down together, or do they usually go one at a time?
So usually when a database goes down, right? If it's an issue with the region, or no, it will never be the region. It'll be hard. The only way a region like West Virginia can go down if there was some kind of a flooding. But even if there's a flooding in Virginia, those regions are located in different parts of Virginia, right?
Yeah.
Multiple. So it's so hard. But then if an availability zone goes down, which is one data center, your application that was running in another data center will still be up. So that's why when you're designing, you have to make sure that if I'm building a VPC or a subnet or an application, I'm making sure that the application is running multiple availability zones. If I'm running a Kubernetes cluster, you're making sure that your worker nodes, which you're going to talk about, your worker nodes are running in different availability zones, right? The nodes that are actually running your application. So you have high availability. I mean, trust me, AWS is pretty stable. Cloud applications are pretty stable, but you just want to be on the safe side. You don't want them calling you in the middle of the night or that something's down. You just want everything to be taken care of. But as you will see, cloud has made a lot of things easy. AWS founded in 2006. So AWS will provide you with compute, storage, databases, analytics, networking, mobile developer tools, management tools, IoT, and all kinds of stuff. I mean, this is me just copying, reading, do my research on AWS and just copying some of the services that they do and posting here. There's a lot more. There's security services. There's config services. There's, deployment services like Amplify. There's database services, there's analytics services. So AWS has everything that you can think of. Anything you can think of, you probably have them. So these are just most of the important ones like compute, storage, databases, networking, developer tools, management tools. Those are the ones that we need to keep an eye on. So I know we talked about storage, right? Storage. So one of the main or the biggest storage is called S3. So Amazon S3 is the #1 storage platform in AWS. So with S3, you can pretty much store anything on here. And I'm going to show you that AWS is not just meant for storing stuff. You can also use it for some cool stuff, which you're gonna see, So you can use AWS to store anything, You have no data limits. So you can store as much stuff as you want, right? There's S3, there's a standard, there's AI, and there's a Glacier. So Glacier, essentially, if I wanted to store something for months or years, I'll use Glacier because it's cheaper, it's slower to retrieve, but it's almost like $0.00 per gigabyte. So it's so cheap. But then it's things that you're not going to retrieve often. AI, standard AI is something that you're going to retrieve within a few weeks or months. And then the S3 standard is what you're going to be retrieving every time, So on high available, things that you can retrieve at any time. So S3 is basically our guy that does all the storage. So when I'm talking about AWS, when I talk about storage, start thinking about files, start thinking about backups, start thinking about database analysis, right? For example, I could pull out my database backup or logs. Think about logs too. You can store logs in S3, right? Think about, in fact, you can store anything in S3. So that's why S3 is so important. That's why I'm starting with S3. Because with S3, it's pretty much where you start, pretty much. If you have any application that's heavy or any file that's heavy, you want to store it in S3 and then you could pull it from there. It'll be easier, right? You don't want to pull it directly from your home machine, and things like that. With S3, you have lifecycle management. So I could say, okay, after 3 months, I want this application, this file to be deleted. You have object log, you have S3 replication. So you could be replicating your information in your bucket to another bucket, just so if it goes down. There's batch processes that run. And then you also have user management that you could do in S3. So, the concept is easier said, but I think it's easier if we can actually go in there. So you can also use S3 for static website hosting. I know some few people, maybe Alpha, you've written some HTML, right? Before you could use S3 to launch your any static application. So we'll see that. And I think I should go in there. So this is what we're going to use. This is the workflow that we're going to do. But I'm going to show you how you can store regular files on S3. And then I'm going to show you how to run our static application on S3 as well. So essentially, you have your users, you're going through what we call CloudFront. And I'm going to talk about CloudFront. And then you're going to hit your S3 bucket. And then we can add Route 53 if you want, but we're not going to include that in this setup. So I'm going to go do the first part, which is running the service, the static host on S3. And then once I talk about CloudFront, I'll show you how you can attach CloudFront. I'll tell you what CloudFront is and how you can attach it. So let's see, let's jump. I know I'm hoping everyone has an AWS account ready. This is mine. Mine looks ready to go. So what I'm going to search here is, before I even go there, I'm going to show you that with AWS, as you look, these are all the services. Let me make this big. These are all the services that you have on AWS. There's multiple services, right? If I go to all my services, you see it's all by alphabetical order. So if you were curious to see what you can find on AWS, you can come here, click services, all services, and you can see we have Amplify. I use Amplify, but you won't have to worry about this. You can develop, push, and all that without even worrying about application. API gateway, that's something we'll keep in mind. App mesh, we don't have to worry about, AWS app config, you don't have to worry about those. So there's so many things that you wouldn't even have to worry about. Athena, I use Athena for data analysis, but you have to worry about Athena, for your DevOps job. But let me tell you what I use Athena for. So when we have logs that are coming from any system, right? It could be CloudTrail logs, it could be database logs, right? I could use Athena to do what we call analysis on those logs. So essentially, I'll use Athena to convert those logs into database tables, and then I can query them pretty much. So yeah, that's super cool. Just some super cool workflows. We have auto-scaling, which we're going to talk about when we start talking about EC2s. This is essentially, setting all your systems. When there's too much CPU load, it's going to scale. It's going to increase. If you had auto-scaling set at 10, it means that if your system has 5 instances running and there was high CPU, there's customers running, the system is automatically going to scale. So there's AWS backup, manage your backup. So just keep an eye on this send manager, certificate manager. So just go through this CloudFront. We're going to talk about CloudFormation. So just go there and look at these services. Just keep an eye on it. You don't have to, you can just look and just read whatever it says underneath. Step functions. This goes with Lambda function. Just familiarize yourself with all these services. But what we're going to look at right now is going to be S3. So that's our storage guy. So with S3, it's not rocket science. All I want to do is if I want to store files from my local machine, all I have to do is create a bucket, right? And I'll give the bucket name. I'll just call it local files. That's the name of the bucket. What region do you want it to be? I want it to be in Virginia. I want it to be in Virginia. ACL is disabled, right? This is access management. Yeah, you want that. And then if you don't want your application or whatever you're storing, if you don't want public to be able to access it, you have to block public access. But think about it. If you're hosting a web hosting application, you want to leave your public access so people can access hidden endpoint, right? But then when we use CloudFront, you won't need it. So I'm just going to block my public access with this demo. And that's it. You build your bucket. Do you want versioning? So versioning in your bucket, what you're saying is each time I upload a new file, it's going to create a new version, right? So I can easily roll back between versions. And I can come back and say, okay, what did I upload before this recent upload, right? And you can be able to use those. And if you're hosting a website, you can see how that's useful. Because if I create a new version of my static website and now upload, I want to see that new content. But if I don't like it, I could roll back to the previous version. So versioning is just a concept to keep in mind with. We're going to deal with that a lot. Tags, I like to add tags, but for this instance, I won't. So that's it. I'll create my bucket. So one thing I want you to know is bucket names have to be unique. When I say unique, I mean unique, not just in your AWS account, but in general, because you can use those as domain names.
What exactly are tags?
So tags are like what you call, okay, let me just give you a good analogy. If you're walking around and you wanted an easy way for people to identify you, right? Let's say you put a tattoo on your hand that says name Alpha, right? So anywhere you go and someone looks at that tattoo, say name Alpha. So that's essentially what a tag is. And you see tag all across AWS. So any resource that you tag, you can be able to manipulate that resource based on that tag. So you see why tagging is so important. So now I could come and say, I want to delete all the buckets that have tag name equals Alpha. It's going to delete all the, you understand how you can start using tagging? So you can use tagging here to try to manipulate resources. AWS, EC2, you put tags and you can control your services based on tag. You can deploy. With code deploy, I can deploy application based on various tags. So I can say if it's tag production, I want to deploy to production. If it's tag staging, then you want to deploy to staging. So you see the idea of tags. So it's very important to keep that in mind. I'm not putting it now, but me as a developer, each time I build any tool, I create tags because it's going to help me later on when I start doing manipulations. So I'm just going to put some random name because it has to be unique. I created my bucket, right? So with this bucket, I already have a bucket here. With this bucket, I could store anything into it, right? I could store, for example, if storing files would be easy as upload. And then I could add files. And you can go back, you watch the video, from my computer. Can you see this?
Yeah.
So you can store any file from your computer and you can be easily access it from anywhere, right? Because now all you have to do is log into your AWS account from any machine and just pull that file. So I'm storing a few files. These are not my file, guys. But anyways, yeah, I'm storing this file now, upload them. And this is basically the foundation of AWS, S3. So you can see my files are here. So each time I open, I can see my files here. So you can store anything pretty much. You can store a file, you can store folders and everything. So that's just one of the basic uses of S3. I see how my bucket here has my files. And now we can talk about, access controls, right? Let me open that bucket and let's talk about a few other things that, you probably do when you start watching the video. So when you come to access points, right? These access points is now you can create, points where you could access that video. It could be your ARN to point to, which ARN is essentially, your AIM identification for that bucket, which we're going to talk about IAM. So don't worry about it. So we come to management. This is where you can create your lifecycle rule, right? So for example, I could create a rule that's saying that, after so and so, I want you to do this to this bucket, right? So I could limit the scope of so this is where you can create a lifecycle rule. So a lifecycle rule could be anything. You can see some of the rules here. Expire current version of object. Permanently delete. Permanently delete. It's going to ask you which version, how many days after. You know what I mean? So with lifecycle, that's where you can start to control your bucket. If you are putting sensitive files and you say, okay, I don't want this to be here after a month, you can create a lifecycle rule. After a month, we'll delete it for you. And then you have a replication rule. Do you want your bucket to be replicated somewhere else? In case if you lose this bucket, you have your information somewhere else. And then inventory, metrics. Remember, we're going to talk about CloudWatch. I don't have the slides for CloudWatch today, but if we have time, I'll open CloudWatch and we talk about it. Your metrics, permissions. This is a big one. So you could put your bucket policy. Let me see if I have a bucket policy somewhere here that we could use. Let me see if I have a demo book. Oh, let's see. So I have a bucket policy. Yeah. So everything that you do with AWS is like JSON. So if I edit this, I could put any policy, right? This is custom policies for us. So let's just talk about these policies a little bit, because once you start doing IAM, you're going to see this a lot. So what I'm doing is I'm referring the current API version. So if you're writing a bucket policy, you always have to have this version. The version is going to be the same. It's going to be 2012, 1017. You're always going to stay the same. And then your statement, you see your seed is to add permission. Your effect is essentially what you want that permission to do. I want that permission to allow. You can put deny. That's when you want to deny access to certain services to certain people, right? But me, I'm putting allow. Principal, star, I'm saying that anybody. Star essentially is for anybody, right? But then you can go in there and put specific ARNs for specific people. I can say only Alpha can access this bucket. This is where I'll put it. Action, get bucket. So I'm only giving them get bucket. But if you wanted to add more, you could add more rows here. You could put a command, put S3, get list bucket. You could put all kinds of rules, right? And then your resource ARN, that's your bucket's ARN. So I'll show you what the ARN for this bucket is. But this is essentially what the ARN is. And then I'll put the bucket name. So my bucket name is local files. So yeah, that's my bucket name. So with this file, what I'm essentially saying is anybody, all they can do is get an object. Nobody will be able to list it. This is that directory except the owner. That's essentially what the bucket policy is. So now you can start to see how you can control access to not just your files, but your buckets and everything. So that's a very important concept to keep in the back of your head. When you're doing research, when you're watching the video, just read a little bit about bucket policy, guys, because I promise you to be a successful DevOps engineer, what I'm giving you is what I do on a daily basis, but you have to make sure that you grab the concepts. You do extra research, you master it, you have questions, you ask me, because what I'm telling you, you're not going to get it in one day. For example, something like this, you can go do a little research. If you have questions, ask me. But this is a very important concept because all across AWS, you have to manage access. Otherwise, anybody will be able to access anything, right? So access management is a very important concept, which we're going to talk about a lot more. But that's just the bucket policy. So I can say my bucket policy. You see, what is it telling me? It's telling me that I don't have permission to edit that bucket. Yep. So there's a bucket policy that's telling me, I can't even access the bucket. So how can we do that? We can go back and reload. Let me reload and see that thing was already saved. So essentially, what it's telling me is my administrator. So what we're doing now, the account I'm using is not my root account. The account I'm using is an account that I created because you don't want to use your root account. And I'm going to show you how to create an account on AWS. So the administrator is essentially going to be the root guy, the guy who created that AWS account. But if you see now, it's not the account that I'm using. And you never want to use your AWS account that you used to create your account, just a security measure. But yeah, it's telling me that, your administrator have updated your permission to allow, put bucket policy action, choose save changes. But what I'm trying to update is, I want to update the get bucket. That's what so anyway, so that's essentially what, so I'm going to add a resource here. Let's see. So you even have a UI here. I never even saw this before, where you can choose what services you want to add and you automatically add it for you on your UI. So, I never even saw this before. You can add a resource. Resource will be this. And you can add all kinds of stuff. So anyways, so that's how you manipulate your bucket policies. I know I have a bucket here that I had permissions all set up. Let's see. Let's see this bucket. Permissions. Yeah, it's the same permission that I essentially use here. So get bucket, so that's the analysis that are essentially the same, but now the only difference is the bucket name, which is this bucket. So I created this file, so I should be able to do the management, but I don't want to waste time troubleshooting this. Yeah, but I should be able to come in here and create the bucket policies however I want them because I created them. But yeah, so I'm having some IAM issues or maybe issues. So we'll talk about that anyway later. But yeah, but that's where you change bucket policies for your file. So what I'm going to do now is we're going to do this, this setup. What I'm going to do is I have a static application on my laptop that wrote in CSS and JSS. So you don't have to worry about what the code says, but I'm just going to upload that to S3 and see how you can be able to display. So anyway, in the meantime, I'm going to create another bucket. I'm going to call it static website Linux. Static website Linux. I'm going to enable versioning just because we're dealing with a website. I'm going to unlock public access. And I'm going to say, okay, I acknowledge that I want public to have access to it, to be able to access it, because this is a website we're talking about. Server-side encryption, that's up to you. And I'm going to create a bucket real quick. So my bucket has been created. This is it, static website Linux. So what I want to do is I want to upload a few static files. And keep in mind that anything I'm doing here, you can also do it using the command line. And every now and then I'll start using the command line just so you can see how the command line works. But I can essentially put files in this bucket using the command line, which we're going to talk about later when we talk about IAM. But anyway, I'm going to add files. Let's see. So the file I'm looking for is another one. See, where is that file? There it is. So as you can see, I have a few files here. This, you have a signup.html. I'll open that. I can open that later for you to see. And these are the files. I'm going to upload those as files. And then I'm going to upload the folders now separately. So these are all written in CSS, guys. These are just, I'm just getting everybody in the habit of, using a code base to work, add a folder, add another folder. That was CSS. Let me add the next one, and the image folder. So I'm just getting everybody in the habit of, starting to use code base. So essentially, when you go to a company, if they want you to run an application, you're going to see something similar to that. I mean, it's not rocket science. You're going to see a code base that you have in your Git repository, which by now I'm sure everybody's familiar with Git, and then you're going to have to run them somehow. So this is just a static application. As you can see, our signup.html. Let me actually see if I can open that file. So we can talk about it a little bit more. Oh, excuse me. Let's see, there we go. So we have our file. You see, this is an HTML file, right? It's an HTML because, it ends in .html. If you launch it with any browser, you're going to see essentially a sign-up page. But we don't want to use a browser. We want to use S3. And then this is just basically, pulling password, and this is just supporting code, right? This is an image that we're using in our code. And this is just some of our styles, CSS styles, right? We just tell CSS, I want to modify this and that. CSS is essentially just a modification tool. So, I mean, all that doesn't matter. I just want you all to know that this is a static application. It could be as easy as me just having one file, sign up the HTML. That's what the static application looks like. So anyways, I'm going to upload that on S3. And yeah, it's uploaded. So what I'm going to do now is I'm going to go back to that same file. And what I want to do is, I want to enable, static website hosting. So when you come here, there's a few other things that we can talk about. I know we enabled versioning. So each version is going to change. So I'm going to show you how versioning applies to this page, right? So in a minute, I'll show you what versioning is. Anyway, so we have our default encryption tags, server-side logging, CloudTrail, event notification. This is where you can set up an SMS topic. I can set up a topic here that's saying that if anything changes on this bucket, send me an email. If someone uploads a file, send me an email, and things like that. This is where you do it. You have event bridge, this just manages events. And then this is what we're looking for, static website hosting. So you come down here, you can enable a website hosting. And you see we're hosting, hosting a static website. You could redirect requests from an object or anything, but what we're doing is static website. And then our index.html, I'm going to say signup.html. And for our error, we don't have an error file, so I'll just put the same thing, and I'll save changes. So now what I'm expecting is whenever I follow this link, I should see our static website. So now we follow the link and now we have a forbidden error. Let's see what it says. Access denied or code access denied. So yeah, permission issue again. So let's see if we can diagnose those. First of all, first thing we want to check is, do we have public access? Yep. All public access is open. Oh yeah, you see. Control ownership of bucket regions. Okay. Okay, let's make some changes to our ownership. Make some changes to our ACL files. Oh, another. And we go back to our permissions and let's look if we have any other thing blocking us from accessing that website. So we still have some forbidden issues. So let's see, what else are we missing? Do we have a permission in here? Okay, so we need a bucket policy. Edit bucket policy, let me see. Let me pull that bucket policy. Where is it? Where's that bucket policy? So when you work with AWS, you have to keep in mind that, permission issues is one of the worst things that you face with AWS. Me as an engineer, I can't tell you how many times that, I have to deal with permission issues left and right. Permission issues is something that you just have to deal with. I have a vendor that we use, and that vendor is always, on my ass, like about permission. So we face permission issues wherever I go, but the issue of permission is to allow safety. So let's see. So do you see any difference with these files? You see, this one is completely public, right? And this one is saying that objects can be public. So this is essentially what we need to do to make this essentially public. I thought I did everything public, but it looks like, there's some ACLs that are blocking me, from doing that. So what we want is this bucket to become public like this one. So we're going to go back and let's troubleshoot and see how we can make that bucket completely public so that we can be able to access that URL. Let's see, where's the other bucket? Let me copy the bucket policy from that other bucket.
When you say ACL, are you referring to the access control list?
Well, yeah, but for this one, yeah, access control list. But for this one, we're talking about bucket policy. We're trying to edit the bucket policy to be able to allow, pretty much anyone to get an object, which is pretty much be what we're trying to do. So let's see, what's the name? Static website Linux. All right, there we go. Looks like it was accepted. Let's see if we have anything else to do. Oh, there we go. So you see our website?
Damn, that's crazy.
Linus is blocked. So I'll do a little change and I'll show you where versioning comes in. I'll go back to that code base. Let's see if I can open this with let me see if I can open it with a code editor. So there we go. We have a code editor. So from Linus, I'm going to say DevOps. I'm basically changing, this is a basic code base. Most of the styling comes from our styles or CSS right here. This is just styling. You see, it's nothing more than just styling, telling you how the body will be, the space in between, the color and all that stuff. That's just a CSS styling. So this is the actual code base that we're dealing with. So I'm going to change develop block I'll change from Linux to develop block, and then I'll change it to create to account to, I'm just put something stupid, you know. I'm going to save this. So now that I save this, I'm going to go back to my S3 bucket, and I'm going to upload one more time. So I'm going to upload. This time I'm uploading just the one file that I changed. What did I change? I changed signup.html. So automatically it already knows that I already have this file, but now this is a new version. So what we're expecting is for this to change eventually. You know, once the bucket finishes uploading, we're expecting this endpoint to change from Linux to develop block if the changes were propagated. So pretty much that's essentially what I'm expecting. So we have our file here. Let's open our file. See. So you see, we have versions of the file. We have two versions, right? There's one that I uploaded not too long ago, and this is a new version, pretty much. So we have two. This is the current version, which is a new one I just uploaded. So what I'm expecting is, where's that website? Where's that link? That sooner or later, I should be able to access the new information pretty much if I uploaded the correct file. So I'm just going to make sure that the file has those changes. Where is it? Let's see, sign up. And keep in mind, guys, you can easily download any of these changes. So if I made a change, like for example, I made a change to my file now, and I'm not seeing that change, I'll come back and I'll say, okay, I want to download that file, and I want to open it to see if the change was actually done. Or I want to download it. In this case, I want to download the file. So I'll download the file and I'll open it. I want to open it using a system viewer. Let's see about that. So as you see, if we open it using a system viewer, we don't have all those fancy CSS calling, but we can see that the file that we saved didn't change. It still shows Linus's bug. That's why we didn't see the update. So let's go back to where we did the change. This is where we did it. We changed it to develop block. Let's save it. And then when we go back to upload the file, I want to preview it to make sure that we have the changes. So open with Visual Editor. Where's my screen? Okay. Oops. Oh, this is the one change we're missing. Develop block. There we go. Let's try it again.
So it might have pulled updated it, but you didn't have that line changed, right?
Yeah, you need to have that. So if we go back to that link, my bad for keep switching. But if we go back to that link, we should have develop block somewhere, but not in all the pages. So I'm going to upload the new file, the new line, or the new file and see what it says. So let's upload, add folder, add file.
So if you have two files that are incredibly similar, the only way you could really, you have to go into the properties and just manually check to see kind of if it's the right one, right?
Well,
other than the timestamp.
Well, it means similar as in name or as in content?
I think content. Yes.
Well, similar in content, then you can easily know which file is which from the name, right? You see how it changed?
Yeah.
So it automatically knows, the versions. That's what version. If I didn't have versioning, like now, I can be able to roll this back and go to the previous version of the file.
Oh.
Yeah, so yeah, I can go to a previous version. I can point you to a previous version where we didn't have, we had liners and all that stuff. So that's essentially what versioning does. Let me see if I can, that's essentially what versioning does. So let's see.
Do that. Let's see how that works.
Let's see. So we have different versions. So let's see. Let me see which one is the oldest version. This one. So share, calculate, move, query.
So can you customize the version ID itself or no? Or is that automatically generated?
Yeah, I think that's automatically generated, unfortunately.
Because that would be a good place to put some information about.
Well, I mean, if you ask me, I can't be too certain if those things are generated random. But if you think about it, those are versions, right? So I mean, there's no way that automatically knows. Yeah, like you could instead of having this, you could say, okay, I want it to be version 1 point this, right? 2 point this, and I think you can do that. I just never done it, but I think you can do that. So an easy way for me to roll back.
You can tell with the timestamp.
Yeah, you could do with the timestamp. So an easy way that I could roll back. I know there's another option here that I could roll back. But an easy way is, if I came here and if I deleted the most recent file, right? That would be an easy way to roll back. So if I came here and it won't let me delete. It's probably because that one is a version that's currently being used. Yeah. So let me look that real quick. In the meantime, does anybody have any questions? So essentially what AWS is telling us is, even though you have different versions, unless that version gets deleted, the only way you can do a new version is to take that same file, do your changes and re-upload it, right? So I think versioning, the most important thing for versioning is, it makes you have different versions of your file. And I could take the same version right now and just re-upload it, right? That's pretty much what the documentations are saying. So by re-uploading a new version, you're pretty much replacing the old version. But you can always come back to download the old version, do what you need to do within it, you can re-upload it pretty much. So that's what the documentation is saying. So yeah, that was good to know. But yeah, that's essentially, it's always good to have different versions in case if I uploaded this one and it was an issue, I can re-upload my old version right here. It's right here. I could just, re-upload it from my computer, or I can just download it from here and re-upload it pretty much. So that's what. So now we have our static website running, but we're going to talk about another concept that is very important. Once we finish talking about that concept, we're still going to use that bucket. So that's our static website running on our S3 bucket. But remember, S3 will store anything. We'll store logs, we'll store files, we'll store, anything you can think of, you store it on S3. So it's very important. So anyways, let's proceed and talk a little bit about this project. So what we're going to talk about now is our CloudFront. We have our S3. We have our static application already running in S3. So now we can talk about our CloudFront. So CloudFront, essentially, what CloudFront is a content delivery and caching service. I don't know if anyone has ever heard about Akamai or any of those services. So CloudFront works well with S3, but it works almost seamless with any domain name. So if no one knows what a content delivery system is, this is essentially what a system would be like if there was no content delivery. So you have people in Australia who want to access information in the bucket. They have to go all the way to Europe to access it. You have people in America, they have to go to Europe. You have people in South America. Imagine how long it would take to transfer information across the ocean to Europe and then back. Well, Felix just texted me saying he couldn't make it. So you see how difficult this would be if people wanted to, make a change. They have to keep going into S3. You have to go far away to get your change, right? This is not beneficial, especially when you have an e-commerce website or any other website for that matter. If I have customers in Asia, I don't want my customers in Asia trying to access my application here in America. If I have customers here in Australia, I don't want my customers in Australia trying to go all across the world to try to access my data here. So if you didn't know, another use for S3, you see we just use S3 to store S3 static images. You can also use S3 to store images that your website consumes. You know, I don't know if anybody has worked with website design and all that stuff, but essentially when you look at, I'm gonna just digress a little bit. When you look at this file right here, you see there's a folder called images, right? If you have a big application running, this folder will be much big, because just don't tell me one man only needs one image. You know what I mean? So you're gonna have a separate folder that's gonna have thousands of images maybe. So what do? You can store these images in S3. And then guess what? By using your public endpoints, right? Like this, or you can even use your private endpoint, you can be able to pull those images into your code base. You get it? So I have my walmart.com. I want images from walmart.com. I'm pulling my images directly from S3 and serving them to my customers, right? So for example, let me give an example. This website, this image, Google Cloud, it could be in S3. IBM Cloud, these images, they could all be in S3. And guess what? I'm just serving them directly using a link directly from S3. And my customers can see them. But you're not storing this image in your laptop or anywhere. So do you get the idea?
Does this apply to videos and GIFs and stuff?
Videos, yeah, you get the idea, Vitaly. That's what, yeah, exactly. Videos and all that stuff. That's what you store in S3, and then websites can be able to consume them. So yeah, that's why S3 is so important. Keep that in mind. S3 is the G, man. You know, S3 is so important. Anyway, so essentially with the cloud, how do you call it, CloudFront, with the content management system, what happens is, instead of my customers coming all the way to Europe to access it, as soon as we have one person from America access this bucket, right? What CloudFront will do is, CloudFront will pull that bucket and put in that user's region, right? So each time someone else wants to access that same bucket, instead of them coming to Europe, they're just gonna access it right here. So it reduces latency and increases speed. And have you ever noticed, so I'll keep giving you guys the hacks. Have you ever noticed that sometimes when you're streaming a video, that video starts very blurry, and then after a few seconds or minutes, it starts clear?
Yeah, so it's like caching.
That's caching and CDN, exactly. That's exactly what we're talking about here. So why it's being blurry, it's still trying to cache that video. Once it caches that video, and remember, sometimes when you access the video, it's blurry, sometimes it's not, right? If you access a video and it's not blurry, what it's telling me is someone close to your location has already accessed that video. And now that video is in your caching location. That's why it's easy to access it easily, and you didn't have the hanging. So you get the idea?
Yeah, yeah.
You saw essentially what content, so you can see how important it is. You know, you can have a website, a small website running with a good content management system, and you can have a small website running. But you could have a big website without content management and you struggle, because it will cache, you can queue, you can also block malicious attacks using your content management. So yeah, it's a very important concept. So I'm going to show you how we're going to use that with our S3 bucket. So essentially what I'm doing with CloudFront is, I'm saying that website that we just accessed, right? The sign up page. If people of, let's say, Alpha and others that are in the East Coast, you know, because currently I'm running in the East Coast, I'm running here in West Virginia. But us, me and Vitaly, if we try to access that link, which I'm going to share in the chat, what's going to happen is going to take that bucket and it's going to put that bucket close to me and Vitaly here. So each time, the next time we go there, it'll be pretty faster than the previous time. So that's essentially what we're doing with that website. So if someone from Australia accesses it, it's going to bring it close to them. So that's essentially the concept. CloudFront is cool. It's really nice concept. So let's go in there and see what we can do with CloudFront. So
what if like three people out of Africa need it and 3 people out of America need it? How does it just send to both, or how does it prioritize? It
sends to both. Remember, it's sending a downloaded copy to that location.
Oh, gotcha.
So what I'm going to do is I'm going to create a distribution. Origin, remember my origin. Your origin could be a website, right? Your origin could be an IP address serving your application. Your origin could be your Kubernetes cluster serving your application, right? Your origin could be a load balancer. Keep that in mind. But here, our origin is our S3 bucket. So this is our origin. So what I'm telling them is, You know, whenever someone comes to that CloudWatch distribution link, I want you to send them to this bucket. Origin path, I'm just going to leave that, you know, open, you know, so any path. So this is where you can redirect. For example, if my website had a slash checkout, that's where I'm going to send a CDN to. If we had slash, you know, cart, I could send that CDN and say anybody that accesses that link on my CDN, I want to send them to cart. So you can start to see how you can start creating microservices off of this. But anyway, we're just working in our S3 bucket. You know, this is a name we're going to use. Well, I'm just going to use default headers. When we come here, what I want to do is I'm redirecting from HTTP to HTTPS. So I want it to be secure. I want my customers to be secure. You know, you can add put post. So if you add put post and patch, what you're essentially saying is I want people to be able to interact with that application through API, and they could be able to load data using put, or they could be able to post by using put and post to post data. They could patch, and they could even delete information from that website. But we don't need any of that right now. Our caching, you know, we're just using the policy, the origin request. You know, we're not doing anything too fancy, but you can start to see how all this can get complicated. I'm using all the edge locations, so all over the world. That's what I'm using. You know, do I have a web application firewall? I don't have any, but if I had a web application firewall, I'll put it here, which means that it's going to block any malicious traffic. But we don't have that now. Do I have an SSL certificate to terminate? I don't have those, so you don't have to worry about those right now. And what I want to do is I want to create a distribution. The goal will be when my distribution is done, it's going to give me a cloud distribution link. And whenever I access that link, it's going to send me directly to my website. But then now it's going to be faster since we're using the content delivery to deliver those contents. So, and you can use this to work with any static website, even the images and all that stuff. I have applications right now in my company that are using static website hosting, like what we're doing right now. And then they're also using CloudFront as the front end. So this is a very nice concept that we're doing right now. Keep in mind, if you go to an interview, you could bring this up because companies are using, like I said, my company is using the same concept where we're using CloudFront in the front end and we're using S3 in the back end when we're displaying static applications. So keep this in mind. This is a very important concept. So anyway, it takes a while for the distribution to get set up. You can see it says here deploying. So we'll just wait for that content to be deployed. Once it's deployed, we'll come back and then we'll try to see if we can access it. So in the meantime, I'll just proceed.
Wait, so if you're using a faraway region, does it use their timestamp or yours?
What do you mean?
Does it matter? Like when you're uploading stuff, for example, like on the date last modified or whatever, it's still going to have all your time and stuff, right? Like, for example, if it's 10 o'clock here and I use like a European region for whatever reason.
It uses the time zone on your machine.
So it's not like a VPN or anything. It's completely different than that, right? It's okay.
Well, this is not even close to what the VPC is.
Okay,
This is actually a full-blown machine.
Right.
There's no company, okay, let me tell you how different this is from VPN. There's no company in the world that doesn't use a content management system, content delivery system. There's no company in the world. That's how important it is.
Wow, okay.
Yeah. Most of them we use CloudFront, and I've also used others. I've used Akamai before, which Akamai is the number one, it's super expensive. But yeah, there's no company in the world. Think about how effective this is. Think about it. Do you know how long it would take to access a video if the video was just in Frankfurt? And do you know how slow it would be? So essentially what I'm telling you is now that we're able to access YouTube videos so fast and so easily, right? We can access videos, Udemy, all kinds of videos so easily. If we didn't have CloudFront or content delivery, that would be a lot different, guys. We'll be having slow systems. Trust me. So essentially, you have to thank this system. When you're watching your NBA and stuff, when you stream your NBA, your Comcast, any other cable, what you're streaming is a video that's so close to your location. That's why you see that speed that you have. If we didn't have content delivery, I'm trying to tell you guys how important this concept is. If we didn't have content delivery, most companies would be struggling, spending millions of money trying to increase their latency speed. But when you have fast videos, have consumption, speedy website, speedy videos, speedy all that stuff, just know this is what is doing the job for you. Just keep that in mind all over the world. So that's an important concept, which I'll say, okay, go back and do a little research. Yeah, but it's what's happening behind the scenes pretty much. So while we're waiting for that to deploy, we talk about a very important concept here. And this is EC2 instances. So I don't know if you've played with AWS before, you've likely played with EC2 instances. Has anyone played with AWS before? So yeah, if you played with AWS before, I'm sure you played with EC2 instances. So they basically compute pretty much. So remember, this is an example. Remember when we downloaded the Linux image and then we uploaded it to the virtual machine just to try to stream it and all that stuff? This is the same thing, pretty much. We're just gonna go to cloud and we're just gonna tell AWS, I want you to give me an Ubuntu system, but I want you to give me a CentOS system. And you can spin it and start using it on the fly without doing all that complicated work that we did, you know? So the image that we downloaded, that would be what we call in AWS AMI, Amazon Machine Image. And then the virtual machine that we run, VirtualBox. For AWS, that's what AWS will provide to us, a hypervisor or virtualization system. So we will need all that. So you see how easy it is to bring up a system, and we're going to talk about that. So EC2 comes to the compute platform. Guys, remember to go back and play with S3 bucket, try to host any website, any HTML. If you want an HTML website or any static website, I'll send you a link. You try to host it, try to use CloudFront and play with it a little bit and all that. But anyways, EC2, you have a compute platform, networking, OS, storage, and all that stuff all set up for you. And then we have something called instant types, right? So we'll go a little bit into that later. So instant type is essentially what kind of system you want. Do I want, remember when we did the VirtualBox and there was a part where we had to give the VirtualBox RAM, right? And memory. So instant types essentially gives you memory, tells you what kind of system you want. Do you want 4 GB of RAM? Do you want 8? Do you want 20? And how many CPU? So it's like a combination of your CPU and your RAM. That's the instant types. So you have to choose those when you build an instance. So there's EBS volume. So that's basically a storage, right? And then you have scalable computing, you know, so this is advantage. There's no need for you to buy hardware upfront. You see how easy it is to bring up a system, you know, CPU, RAM, high availability. You have your firewall in the name of, you know, security groups, which you're going to see. So these are some of the major instant types that you see. We have T2. You see, it's bustable, good for changing workloads. We have M5. This is M, memory intense. So if you have a memory intense application, we have C5, you know, a high ratio of compute to memory. So you see what all this means soon. You know, this is just like a big foundation. When you're going through the slides, this R4, you see, is good for memory databases. And there's different categories of instant types. So I'm going to follow that link right here and see if we can go to this a little bit more detail. So I posted this link in the slide. So with this link, you'll be able to see all the slides that you need. For example, you have instant types like T2 4 nano. It tells you that you have 2 CPU and, you know, 0.5 memory and all that stuff, right? You see how we're going to use this, but keep in mind, this is a very important concept. If you go to T3, there's different instances. You see this one has 2 CPUs, 6, you know, CPU credit hours and 0.5 memory. This one has 8 GB of memory. This one has 32. So this is a heavyweight. I use a lot of this. You know, 4 CPU and 16 GB of RAM. And there's T3, there's T2, there's all kinds. There's M. The M stands for memory intense. So you see, they have a lot more memory. Look, 384 GB of RAM. So when you see M, you know it's memory intense. T2, so this is the one that is free. So when we create an instance, you want to create a T2 micro. 1 VCU and 1 memory. Apparently, AWS says if you do this, they're not going to charge you. So I'm going to go ahead and create that. And when you watch the videos, go ahead and create something similar. So what I'm trying to do is I'm trying to create a virtual machine, pretty much. So go to this link and just look at it, the instant types, you know, just read a little bit. But when we go to our slide, where is it? So this is our AWS account. Let me see what time it is. So already at 7:23 and people are getting quiet. So maybe we should take a little break and then we'll continue. Is that cool?
Yeah, sounds good, man.
Yeah.
Hey, Hey, I know people have already asked you for this a million times, but could you send the link to the YouTube videos one more time? For some reason, I saved
Yeah,
it,
yeah. So,
liked it, but for some reason disappeared.
so class, if anybody has a link, can you post it real quick? Otherwise, I can do that later. Well, let me see. I probably have it right here. Let's see. Okay, there it
So
is.
is it the playlist? So the Linux playlist, that's different, right? You split it into two, right? Or it's the same
Well,
one?
it's the same one. The only
Oh, okay.
difference is, as you can see here, the only difference is now the new videos are coming, they're private, you see? So I'm only giving access to the people that are needing to watch the videos.
That's why I'm on my wife's YouTube account. So it keeps telling me something was wrong, but I'll re-sign in.
Yeah, you need to sign in with your Vitali. You know, I don't want people going in, you know. So yeah. Eventually I'll turn some of these to private.
Okay. That makes sense.
Yeah. So yeah, I see you guys in 10 minutes. Well, looks like we already see you in I don't know, in 9 minutes. And we can continue. What do you think about AWS so far? If you're still here. It's nice.
It's crazy.
It is crazy.
I never knew that the whole how you use links and stuff for like the videos and pictures.
Oh yeah, you know a lot. That's DevOps. Yeah, see you in 8 minutes, man. Take a break.
Yeah, all right, sounds good.
Hello, are we back?
Yeah, we are.
Awesome. So how is everything sinking in so far?
How's everything what?
Sinking in so far.
I mean, to be honest, it's all going over my head. I have to go back and because it's like a lot of information, you know?
It is, it is. That's why this class takes so long. Well, I'll make it take a little longer because with a lot of information means you need more time to digest.
Yeah,
and,
exactly.
And that's why I took the classes to 2 times a week. So you have all weekend pretty much to catch up. Because trust me, guys, whether you like it or not, on the weekends, sometimes I'm working. Yeah. To catch up for the week. So weekends, you can vacation all you want, but me on the weekends, most weekends, you find me writing code sometimes. Or you find me just trying to catch up and get ready for the week. So
What language do they make you use for the code?
Well, I use, most of my infrastructure code, I use Terraform for my infrastructure. For Kubernetes, I use YAML files. We call them manifest files for Kubernetes. So it's a different kind of language. For programming and automation, I use Python and Bash scripting. So we're gonna see YAML. Don't worry, when we start doing Kubernetes, you see what YAML is. When we do Terraform, I think Terraform is more important. When we do Terraform, you see what the Terraform language looks like. Mm-hmm. And then I also, occasionally I'll go in the code base and take, but you don't have to do that. I'm just being adventurous. But anyways, let's see. So now what I want us to do is, I want us to go in there and first of all, let's see if our CloudFront is completely finished defined. Yep, looks like this is deployed. So I'll open it real quick. And can we see our distribution domain name? So now, essentially, there's another error. We have access issues. So our CloudFront, what's happening now is our CloudFront is trying to access our bucket, but our bucket has some permission issues. So let's go back to our CloudFront distributions. This is another one. Let's enable this one. So this one that I'm enabling, it's going to deploy again. Anyway, let me go back to my static bucket, and say, okay, why isn't CloudFront, being able to, to pretty much serve my content. So if I go here, it's able to serve the content. So what I want is for CloudFront to be able to go through to that same bucket. So let's see. Let's look at the permission issues again.
Are you going to go back and copy the policy from the first one?
Well, yeah, the policy, at this point, the policy looks like it's fine. So you might get issue with the, how do you call it? The bucket, some intense bucket policies and stuff. So I might look for another bucket policy. Because, you see this bucket, right? Get object. This is supposed to be able to allow CloudFront to do whatever it needs to do. So yeah, that should be enough to allow CloudFront to do what it needs to do on that bucket. So yeah, so for example, let's see, let me go back to my CloudFront distributions. Yeah, this one is still deploying, let's see. We have it, this one deploying. We'll get to that when it's ready. Yeah, I don't want to waste any more time here because we have a lot to cover, but. And enable another CloudFront distribution that points to the other bucket, and that should get us going. So remember, there's two buckets here. There's this bucket. It has pretty much the same files. Oops, is it empty? I thought it had the same files. There's this bucket, and then there's this bucket. So I'm just gonna go ahead and upload the same files to this bucket. Let's see.
So jealous of your internet speed.
What?
The internet at my house to upload or download something is so long.
What internet service are you using?
Sparklight.
You have Sparklight?
Uh-huh.
Go to fast.com and see what it says. What does fast.com tell you?
Well, it says 12 megabytes per second, but the download and upload speed is like way lower.
You say the download speed is, the upload speed is 25?
No, download speed is way smaller. Hold on.
Anyway, guys, this is one of our platform distributions. If we look at the origins, we see it's pointing to one of our S3 buckets. This bucket, this particular bucket right here. And it's pointing to our bucket. And what we're expecting, like we said before, is this will be our new link, right? So if let's just assume that this was walmart.com, right? So what will happen is our DNS walmart.com will pointing to this distribution domain right here. You know what I mean? So each time someone hits walmart.com, it's pushing them to this content delivery, pretty much. You get the idea? So let me put that again. You see? Now I'll share this with the chat and see if we can access them from different locations. That's a CloudFront URL that I just posted. See if anybody can access that one. That link.
So when Walmart, well, for example, if Walmart releases a version of their website that has an issue, and then they want to like re-implement the old version, is there technically a point in time where there's nothing on live on the air, like between, or is it pretty instant to where it like switches it out?
It's usually instant. So this S3, right? What we're doing is we're deploying static buckets. So a static bucket essentially is something that you can quickly test in your machine to see if it's okay, right? But companies like Walmart, for example, they're going to be using sophisticated deployment pipelines like Jenkins, right?
Yeah.
And when Jenkins fails, automatically when you build your pipeline, you want to make sure that if your pipeline fails, it automatically rolls back.
Mm-hmm.
Yeah, so you pretty much have no downtime because what happens is, if you notice that this deployment is failing, it's going to just revert back to the old parts that we're running and then just kill them pretty much. So you get the idea?
Yeah, yeah.
So anyway, the next concept that we talked about, let's see, what does that slide say? Where's my slide? There we go. There we go. So we're talking about EC2 instances. So what we're going to do, I want you to keep in mind, this is a very important what we're about to do. And I also want you to keep in mind that whatever we're doing here, I'm trying to close this. Whatever we're doing here on our desktop, remember, always keep in mind, whatever you're doing here on your machine, you can also do that using this terminal right here. If you do the right connections to your system, which we're going to talk about later. Well, I'm still connected to the Ubuntu. Wow, look at that, you see? I'm still connected to my system that I left since the last class. That's on cloud. But anyway, let's go back and create a new one. So I'm going to exit real quick. So this is AWS. So if I want to create, if I wanted, so Vitaly or anybody for that matter, if you wanted to create a virtual machine, right? That is, I want an Ubuntu, or I want a CentOS, or anything of that nature, that I don't have to buy a laptop, I don't have to buy another, VCU, whatever you need, right? This is where you go. You come to EC2, which I search here. When you go back to the video, you can just search EC2, and this is the first one that pops up. You click on EC2. It's called Elastic Cloud Compute. So let me show you how we can bring up the same system that we were using before. So you launch an instance, right? And this is where you search. What do I want? Do I want Ubuntu, right? These are the Ubuntus that come up. That's how easy it is. Do I want, I don't know if they have CentOS, but do I want CentOS? They don't have CentOS. Do I want Red Hat? Or they don't have Red Hat. Do I want Amazon Linux, which is essentially the same thing as what we've been using? So I use this a lot. Amazon Linux is basically CentOS. We still use, all the, and then, or do I want, let's see, Microsoft? Do I want a Microsoft system? You see, I can spin up a Windows server and be able to SSH through it using RDP. And I know someone is familiar with this concept, Bajo. I think we've done this before with Bajo, where we've been able to spin up some Microsoft instances. Yeah, this is where you do it. And then able to RDP through it and just use it like a regular Microsoft.
Yeah.
So yeah, this is where you do it, Bajo. Anyway, we're not going to do Microsoft. For Microsoft, all I have to do is select Microsoft. That's the only difference. But we're going to do the Amazon Linux, which is basically the same thing as, as CentOS. So I'm just going to select this 64-bit. And then now it's going to ask you, what do I want? Remember, I told you this one is the only one that is free. You see, it says here, T2 Micro. So if you go home and you wanted to create a server on your own, you want to create this T2 Micro here because it will be free for you. So I'm just going to pick that. I could create whatever. I could take T2. You can see 2 CPU, 0.5 RAM. You can see if you want something that's very RAM heavy, you want to be targeting, the T3 2X large. But, I'm just using for demo purposes. So I'm just going to go my, my T2 and I'm going to go next. I'm going to go my configuration. And this, I want you guys to keep in mind whatever I'm doing here. Because most of the things you see here, we're going to talk about them in details because you have to know about them in details. But right now, it's AWS, they do everything for us. Do you want to launch this into an auto-scaling group? So what I'm telling them is if I wanted to launch this into an auto-scaling group, I'll put 3. And what I'm saying is each time one system is overloaded, I want you to launch 2 more of the same system pretty much. But I don't want to do that, so I'll leave that at 1. You want to request pod instances. So pod instances are essentially cheap instances, right? So pod instances are instances that you can borrow, but they're never available at all times. So, but you can borrow them and they're much cheaper. And then networking, keep in mind, we're going to talk about this in details, but network, you need a VPC always. This will be for next class. You need a VPC. Luckily, whenever you create an AWS account, automatically you have a default VPC right here. We're going to talk about VPC and how you can create your own VPC, which you have to. Subnets. Remember class when we talked about different availability zones, right? So this is US East, I'm in Virginia. So this is one availability zone, 1F. Remember when they say they have 6 availability zones, 1, 2, 3, 4, 5, 6. So these are different regions in Virginia. So if I launch one application here, and then I launch another application in 1D, then essentially in 2 different regions. 2 different availability zones. So I want to launch mine in US East 1F. That's the one region that I want to launch in. And then let me show you something real quick. If you look here, do you see the different regions? If you wanted to change the region, this is where you do it. You just click here and you change to US Ohio. But remember, if I create this instance in Virginia, if I change to Ohio, I won't see that instance. You see that in a second. Or to Hong Kong. So this is where you can easily change locations real quick. And then this is where you can easily see your billing. So we'll talk about that. That's very important after that. So I'll choose the default subnet, this auto-assign public IP. if we're going to talk about this, but if you want your system to essentially have a public IP, which I want it's very important for SSH. Hostname type, IP name, I'm not too interested about that, but, I'll just use the IP name. DNS hostname. So you can leave all of this default, but I just want to talk about it. So if you wanted to create an instance role for your instance, this is where you create it. So these all sound like rocket science. When we start doing these services individually, you understand. Like we're going to talk about AM rules, you understand. Shutdown behavior, stop or terminate, I like stop. And your tenancy, all this stuff, monitoring. Do you want to enable CloudWatch? Well, I'll just enable it for the sake of it. And all this other stuff, file system, this is how you can create your new file system. What we call EBS volumes for your instance. So I don't need any of that. So I'm going to go to next. And this is where you can add your storage. I just want 8 GB, but you can add a new volume. You can add volumes upon volume upon volume. And you can just add this, add your file system. And then next, remember after you asking about tags, this is where I can say this environment is quality assurance. Or if it's production, I can say this is production, right? So anyone that here knows that this is a production system, so you don't mess with it, So you can use a tag to be able to differentiate. So this is another important concept which I'll talk about. So I'm just going to use a default security group, but I'll talk about security groups and what they do. So just keep in mind, security groups is like a EC2 instance firewall. So you can determine, I know I showed it last class briefly, but you can choose who can access your EC2 instance, what IP address, what port and what IP can access your EC2 instance. So right now I only have 22 open and 22 is for SSH, which means that I'll be able to log into this server from my local machine. As you can see here, custom, I said you can access it from anywhere pretty much. So anybody will be able to access it into the system. And then review and launch. So these are some details. I choose the Amazon Linux EMI. I could have chosen Ubuntu or CentOS, but this is essentially CentOS. I choose T2 Micro, my security group. All I'm doing is I'm allowing SSH. But there's so many things you can allow. For example, I can allow HTTP here or HTTPS, which would be 443, which means that I want to use that as a web server, right? These are some of the instant details. These are all, blah, blah, blah. And then we can just launch this. And this is where it's going to ask you for key pair. This key pair is very important because this is what you're going to use to log into that system. You see how I'll do it in a minute. So I already have a key pair that I created, but if you didn't have a key pair, you can just say create a new key pair and you give a new key pair name and then you download it and it's going to download it to your machine. So I already have a key pair, so I'm not going to create, I'm just going to use the one I have. Class, and I'm just going to launch my instance. So that's it. I have my new instance running. While I have my instance launching, I want to talk about something else. There's something in the instance that we call user data, right? User data is how you can be able to do things on your machine pretty much before it gets created, right? On the fly. So let's see, let me just go back real quick to our instances and see if I can find the user data. Let's see, do we have user data somewhere here? Exactly, you see this user data here, class?
Yeah.
This is essentially where if I wanted to install something before the machine starts, this is where I'll put it. So let's just say me, I'm a bash guy. So I want to put my shebang. Remember the bash scripting we did in Linux? Remember? Mm-hmm. We did bash. Remember bash scripting? I could say sudo, yum, I want you to install, I want you to install Apache. Or I want you to install whatever, I just sudo yum, I want you to update the system, whatever. This is where you put it. So when the system starts, guess what? It's going to run this command first and install whatever application you needed to install. And then it's going to start the instance. So let me, I'll do that on the side. So you can see how that works. That's a very important concept. So I'll create another instance with the user data so you can see what it does. So I'm just copying this one from online. So this is a basic bash script. So if you forget about bash script, I want you to do a review, but I'm going to say exactly what this bash script does. So what I'm saying is when I create this instance, I want this system, what I want it to do is I want it to update itself, right? Right?
Yeah.
I want it to update itself. I want it to install LAMP stack. I want it to install HTTPD and also, you see the HTTPD, Apache. I want it to also install a database server, MariaDB. And then I want you to start HTTPD, right? And I want you to start, not just start HTTPD, but I want you to enable it. These are just one-off commands that you can run on any Linux system by yourself, pretty much. But we're putting in a bash script. So I want you to start HTTPD. I'm going to paste, I could paste that in the chat, or I could paste that in the slide if you want. I want you to change the user, to Apache user, just basic. You remember these commands, guys? We're changing ownership. Remember, we did all of this in Linux. Change mode, change owner. Now I want you to find this file, and then I want you to change it. So this is a basic shell script. So when we're done, what we're thinking is whenever I take the public IP of this instance, I want to see that all of this has been installed pretty much.
You're gonna do that every single time you open it?
It would do that every single time you launch a new instance or you make a change to this instance, pretty much.
Gotcha.
So it's like a way of, do you know what we mean by to bootstrap, right?
Mm-hmm.
It's a way to bootstrap a system, pretty much.
Gotcha.
So anyway, so I'm going to save that. I'm just going to go ahead and launch it. So I'll be launching 2 instances. Let's launch. Let's make sure, I'm just going to use the same user data. And I want to make sure that it runs. So we'll go back. And we should have multiple instances running, right? We have the one that I'm logged into before when I did the class on. And then I have a new one that I just created. Where is it? Let's see. What time? Yeah, what time is it? So is this one? I think this is the one that I just created. And then this is the one.
Yeah, okay.
Let me just put names to them, to be honest. HTTPD, new. And I'll just go ahead and terminate this instance, the old one. So this is how you terminate an instance. So sometimes you have to do this at work. You won't believe it, but I have to do this at work. Sometimes I have to reboot an instance. This is where you reboot it. So when you go back to watch this video, just keep an eye. This is where you stop the instance. This is where you can reboot the instance. And this is where you can terminate it. So I'm just going to terminate one of my instances. So that's where you do it. So now, another concept that I want to show you, what time is it? 7:57. So while my user data system is installing, you see it's taking longer. It's going to take longer than all the other systems just because it's going to do some installations for me, you see? When he says initializing, he's doing those installations for me. That's why it's going to take long. Anyway, so this concept, guys, the last interview I did for a friend, I didn't want to do that, to be honest. But anyways, they basically wanted you to create an instance like this and then install Jenkins on it, pretty much. But now we already created the instance. So I want to show you how you get into that instance. Remember, we created a key pair, right? So when you create a key pair, if you're using a Mac, it'll be easier. If you're using a Windows, I want you to download something that we call Poddy. You can do the practice later. This is it. If you have a Windows system, I want you to go download Poddy. You can do it right now. You can do it after the class. But that is what will be able to let you SSH into the system, pretty much. So if you have Windows, I want you to download that. If you have Mac, good thing you don't have to, So let me show you how you SSH that system. So I want you guys to pay attention to this.
Daddy, I didn't open this.
Okay. You can go. You're busy. Lock the door. Shut the door. Lock the door. Oops. Anyway, so guys, I want you to keep on. This is it looks very simple, but it's very important. If you want to log into this system that we just created, you come here, you click on connect, right? and you see this fancy page is going to open. So this is what you're looking for. Copy this. And then go to your machine. This is my terminal. Remember, you downloaded a key pair, right? So if I ls and I grab -I should see my key pair here. You see my key pair? So when you create an instance, it's going to tell you to create a key pair, which you're going to create and you're going to download. Once you download the key pair, the first thing you want to do is you want to change the mode of your key pair to 400. Otherwise, your key pair won't work. So sudo change mode 400 and then your key pair. Once you do that, it's going to ask my password. Mine is already changed, but I'm just doing it just in case. Once you do that, I want to show you the permissions so you can see that the permission has changed. ls. This is Linux. That's why I told you Linux is so important. You see the permission of my file? You're giving read access just to the owner. That's the only way you can do, otherwise your key pair is not going to work. That being said, remember you copy this right here. I come here and I paste this. You see, it says that I my key pair. If, let's say, for example, your key pair wasn't here. Let's say my key pair was in a different folder or directory. You're going to put that directory here. But mine is in the current directory, so I just put the name of the key pair. And I'm going to SSH. It's going to tell me yes. And yes, you see, I'm inside the system, guys. That's it. You see, who am I? I'm an EC2 user. I'm in my EC2 instance. That's it. And trust me, this is one of your fundamentals of working as an engineer. You have to be able to go into a system and see what's going on.
And how do you remember all this stuff?
Well,
you're so fast. You're just like boom, boom, boom.
Well, that's why we have the video, guys. The video is going to be your best friend. You know, everything I'm saying is on this video. You know, remember to SSH into an instance. And if I'm too fast, just tell me I'm too fast. If you have questions, just ask me. You know, and just connect and just copy it. Right here, everything is so easy. AWS makes everything so easy. This is it. That's all I did. And then I pasted it here and I logged in. So now I'm in my system. So now I can start running commands like sudo yum update -y. And it's going to update my system for me. See? So you can run any Linux command that we've been practicing on this instance. Yeah, go ahead, Bajo.
Yeah. So when you try to get into that system, does it actually tell you that you have to actually change the permission before you go?
If you don't change the permission, it will tell you that the permission is still open. You need to change it.
All right, so it tells you the exact person you need to give permission to in order to access the system.
No. It's telling you, remember, you're going to use this file, right? The permission file.
Yeah.
If you don't change it to 400, AWS will reject you. It will tell you you can't access this system, your permission is still open. So you have to close it to 400. So only you, the owner, can access it.
All right.
You can read it. So we're back to permissions. You know, I told you, you know, from day one, Linux is so important. You see how Linux is factoring into everything?
Yeah.
Yeah, that's the why Linux is the foundation. It's factoring into everything. I'm running simple Linux command. This is a Linux system right here, but it's running in the cloud. So let's go back to the other instance that we use the user data on. These videos will be your best friend. This is the one that we installed HTTP on it. So if everything went well, what I'm thinking is if I access this, I should see some kind of an HTTPD come on the screen. So it's loading. So this is another good exercise. So now it's loading. So what it's telling me is, you know, I need to look at my EC2, you know, security group. Right? We're going to talk more about security group, but
Daddy,
oh my God.
one.
How many bottles of water are you going to open?
Five. I want this.
I don't want to see you here again. Go. Man, I can't believe that's going to be in the recording. Anyway, so now I'm loading and nothing is happening. Who can tell me what's going on?
Is it still initializing or something? Because it has to, I don't know.
No, what's going on is I'm trying to access the system on a particular port, but that port is not open. So the security group manages that. So let me open the security group and I'll show you how. So we're going to talk a little bit more details about this, but just keep in mind what I'm doing. There's a secret section for security groups, which we're going to talk about. But what I'm doing is I'm adding a rule. Keep this in mind. You will do this so many times if you become a DevOps engineer. You might not do it on the console, you might do it in code, but you do this so many times. What I'm trying to do is I'm trying to provide HTTP and HTTPS access. And essentially what this is nothing other than just me opening our ports to access a web server, pretty much. You see that?
So, yeah.
So anyway, go ahead, Vitaly, you had a question.
I was gonna say, so the reason it wasn't opening because it was technically the wrong format, the file type was different, or is the HTTPS, is that just permissions?
Yeah. So what was going on is, where is that? Where did I change that? Where did I change it? Oops. My bad. Where was I working on my AWS? You can see. Okay, right here. So what was happening is, remember when I talked to you about, let's say Walmart.com, let me open Walmart.com.
Oh, yeah, I remember.
Yeah, Walmart.com, you see, it's asking me if I'm a robot. But anyways, you see this here?
Yeah.
Essentially, for Walmart.com, if someone behind who was working at Walmart blocked 443, right?
One vote.
And port 80, but let's just do 443 because that's secure. If someone blocks 443, then I won't be able to access Walmart.com in a secure shell, pretty much.
Oh, gotcha.
So that's what happened. So yeah, so know that Walmart is currently, we're accessing Walmart right now because, and the only reason is because 443 is open. That's why. So remember we talked about our user data. Remember that? Our user data was supposed to install, HTTPD, which is Apache, do some changes, copy our file. So you see that we have a system that is already a web server, but we didn't have to do anything. Right?
Yeah.
That's what the user data does for you. You already created a web server for us. Just with those commands. Let me show you those commands real quick. So remember this. So he created Amazon extras. He did a LAMP stack, MariaDB, database, PHP, and other stuff. He installed HTTP database server, and system, he started it and he enabled it. And I could go into the system and show you a little bit more about that if anybody's curious. So now, because of that, we have this already ready. This is our test page already ready. So if I copy any HTML web page, right, and I stored it in this directory, var www.html is going to display that web page right here. Because we have our web server already ready. So keep that in mind. That's what user data does, Tim. As an engineer, you have to use user data at some point. So that's what user data does. So we already have everything installed for us without even doing anything, pretty much. Because of these commands, using the user data, they're able to do everything for us. So you can think about, you can do anything here. Badger, you could do any service, Vita, anybody, you can do anything. You can install anything you want on this user data and do it for you. This is a simple bash script.
Wait, is that a standard bash script for servers?
Well, a standard, but the only difference with a standard bash script is this one here. Everything else is just a regular command that you can run on any Linux system. So you could run this on a Linux system, you could run this separately, you could run all of this separately, but we're putting it all. That's why bash script is important, because you're putting everything in one script and let it run for you. Remember, automation. This is an easy form of automation right here. Yeah, guys, IT is not easy, but it by no means hard. I mean, think about these things. If you do this 1, 2 times, that's it. You already got it. 3 times at the most, you have it. So don't let this scare you. These are things that I had to learn as well. And I just did a little bit of practice and I was able to, learn all these things. So take it slow. We're doing this class twice a week. So take your time. Don't sleep on it. You need to watch the videos. If you don't, you're not going to catch up. But if you do exactly what I'm doing, you have questions, you ask me, this will be all easy stuff and everything's going to make sense to you. So yeah, that's what user data does. So I had to cover that a little bit because it's an important concept. So we have our EC2. So what I'm expecting is next class, everyone should go and create an EC2 instance. And when you create that instance, I want you to be able to SSH into it. For people using Windows, just Google, how can I log into an EC2 with PuTTY? You see easy, it's 4 steps. The step where you upload your certificate and the step where you put your username. But for people using Mac, just follow the same procedures I'm using. And you can log in. I want you to create your EC2 instance for next class. I want you to SSH into it. And then when you're done, make sure you go back, destroy your EC2 instance. And then I want you to create another EC2 instance again. And then I want you to use the user data. So I'm going to add this link to the slide. But remember, your user data doesn't have to be all this. It could be just 3 different lines. Where do I put that code? The user data code. So I'm going to put that link in the slide. I'm actually adding it right now. The link to the user data. You're going to see in the slides, you're going to see user data. Let's see, user data, where is it? User data. So in the slide, when you see user data, you see the link to that link. But you can use the same thing. You can use the same user data, just see how it works. But you can just change the scripts and just put whatever you need to put in there. You can do as easy as, let's go back. Let me open a note. You can put this in your user data. I just want to show you that, you don't have to put the most complicated things. So I'm going to open a node right here. So I could put this in my user data just to make sure it works. I could put this bin bash, and then I could say sudo make directory DevOps, and I could say sudo copy DevOps into my home directory. That's it. And when you SSH into that instance, what you want to see, or you could just make the directory, it's going to automatically create that in your home directory. And when you SSH into the system, all you can do is ls to see if your DevOps was created during initialization. So I'm just telling you, you don't have to do rocket science. This could be a user data script right here. You just want to test that concept, to see how it works. So I'm going to post this in the chat. You could add anything to it, any kind of user data. So your user data doesn't have to be complete. This is just making a directory. You can also make a directory and store some files in it using your user data, and you do it for you even before the instance starts. So when you log in, all you do is ls to see if you actually created that directory. You know what I mean? So yeah. Let me see what time we have. Oh, we have, so any questions?
Not really a question, but more of like a comment about the last YouTube video you posted. It's like a different YouTube channel, not the first 4 videos. It's different from the last one. Like it's not on the same platform. It's different.
Well, it is in the same platform. The only difference, like I showed before, is private, which means that to access it, the email that you sent to me.
No. I can access it. I got it. I was just wondering if, but I mean, I guess you answered it because you said it's private, but it's like a separate video because we had like the first 4, and then
no. It should be, if you have access to the video and if you logged in using the Gmail, you should open that same playlist and you should have all of it there.
Oh, okay. Maybe I did not look well. I'll check it.
Or maybe you logged in with a different YouTube account.
No, I only have one.
With that same email, right? Okay. Gmail.
Pardon?
With the same Gmail, right?
With the same Gmail, yes, sir.
Yeah, just let me know if you face issues. Any other question?
I mean, I tried all three of my Gmails and it doesn't give me access. So maybe I forgot which one it takes me to your channel. It takes me to Linus Sano, it's 6 subscribers, but then there's 0 videos.
Yeah, it just won't give you access if you're not. So let me see what email we have here for you.
Yeah.
There we go.
Oh yeah. Huh, that's weird. I try it.
Did you receive any notification email?
A long time ago, like the first time you sent it out, right?
Yeah, I mean, I'll try to go through there, but yeah, you should be able to, everybody in this email should be able to access it. And very soon I'll put all the other videos private as well. Any other question? Yeah, I want you guys to hang in there, guys. Trust me, you know, a lot of people, not a lot of people, but some people are going to, you know, drop out and all that stuff. You know, because it's not easy stuff, but at the same time, I promise you it's not hard. So hang in there, you know, there's always going to be people that are going to finish. So that's a guarantee. You want to be among that list.
Yeah, I want you to go back to the part where you explained about those 443 and the 80 port. Let's understand what happened there.
Yeah, there's actually a separate slide for that I'll be coming on soon. But yeah, I could go back. There's a separate slide that I'm going to talk specifically about that. So just be patient, we'll talk about it soon. Now, would you laugh? It's actually 2 slides from here, so it's not too far away. So this is another brief concept I'll just talk about real quick. And then you see the security group, we already did this, so we don't have to worry about this anymore. So I'll just talk about the load balancers real quick. So on our system, we have something called load balancers, right? This is exactly what the name says. So you have your content delivery like CloudFront, right? It manages your content. But then when users are making requests to your website, for example, you have multiple people hitting, you know, Walmart.com and all that stuff. You want to make sure that multiple customers are not hitting one system alone, right? Because if you have Walmart.com, or if you have any other website, there's probably 10, 20, even 50 or 100, or even a website like Walmart, if they're using just virtual images, you could have 1,000 of them, or even 100 of them. If they're using Kubernetes, you can have a few thousand pods running, or even 100 pods running, right? But they're serving the same application. So how do you make sure that, you know, one pod, one system is not getting overloaded, right? That's why you use something called load balancers. So if I attach a load balancer, if I have a web server running, you know, and I have web servers running on an auto-scaling group, right? An auto-scaling group is a group that scales, that you can put the auto-scaling group to scale based on anything. It could be if my CPU is high. It could be if I have so many customers. So you have that auto-scaling group, but then you need something on top of it that's going to share the load, right? So if I'm Bajo, I want to access this web server or this load balancer. When I'm accessing that server, if another person comes to Walmart.com, I don't want him to access that same server that Bajo is already on. I want him to access another server that's going to serve the same content. And what you're doing is you're trying to manage the load. So one system doesn't go down because there's too much load on it. You understand the concept? It's totally fine if you don't understand. I think a demo, we'll explain it. So I'll do a demo next class, just so I don't hold up, because I have to create 2 instances in our auto-scaling group, you know, have them running a particular web page, and then I'll switch between the load balancer. So I'll do that next class for sure. I'll do a demo so you understand what the load balancer is for sure. But this is essentially what the diagram is. You have a load balancer, you have 2 listeners right here, and then they have different targets. So the targets are serving the same content, but they're all streamlined in different. Remember, we talked about regions and we talked about availability zones, guys. So you could have a server here in Virginia, 2 servers in 2 different availability zones in Virginia, and then you have another server here in California, 3 different servers in California. They're all serving the same content, and you have a load balancer that is managing the load, sharing the load between the different users. Is sharing the load. So if this system goes down, you still have 4 more, and you have a load balancer just sharing the load and making sure that this guy doesn't have too many users at one time when this guy is idle. And same for the other one. So you get the idea. Yep, class is awfully quiet.
No, we're getting it.
Yeah, watch the video, guys. If you have any questions, feel free to call me. But yeah, I'll set up a demo for next class. I'll need to write an HTML file that I can easily change. I could use the same CSS, deploy it to an instance, and then we could swap between 2 load balancers. You see how the load balancers work pretty much. So I'll do that next class, so keep that in mind. So let's talk a little bit about key pairs. So remember the key pair that we just downloaded, right? Those are SSH key pairs, and that's what you use to access the system. And then there's something called AMI. Remember when we choose Amazon machine image, and we also choose, there was a part where we could choose Ubuntu, and there was a part where we could choose Windows. All those is what AWS call AMI. Those are machine images. So let me just go back to my profile and show you that real quick. So there's a separate instance here for AMIs right here. And if you click that, you can see AMIs, private, public. So I'm just go to public. You see these AMIs? These are all machine images that you could use if you wanted to. Some of them will be, you see some of them are Ubuntu. So this is what AMIs are. And when you launch an instance, it's going to ask you, do you want Ubuntu? You're going to see that part where we're searching which one you want. You're basically searching an AMI. So keep that in mind. You see, we even have a Red Hat here. I was looking for Red Hat. So I could put this AMI here. All I need is to take this ID, and I could put it in my script or in my instance. I'll be able to create an instance using this same AMI image right here, Red Hat. Does that make a little bit more sense?
Yeah.
Yeah, that was, but anyway, yeah, just go back, like I said, you need to watch the video at least 1 more or 2 more times. You can skip between it if you want, but when you get to the concepts that you didn't understand, you can rewatch the videos, and then from there, you can then ask me questions. But I don't appreciate anybody asking me questions if they haven't really watched the video, because when you watch the video, you will not only have more questions, but you have more foundations to build off of. So, and then you can use something called Packer, which I'm going to mention when we talk about Terraform. And you can package AMI. So that's just some small concept that to keep in mind what AMI and key pairs are, because you use those as a DevOps engineer a lot. So my assumption now is, does anyone understand what AMIs are?
Yeah, I mean, you just, that's what you just explained, right?
Yeah, so I just want to make sure that we know exactly. So when I say AMI, what am I talking about?
From what I got, it's like virtual machines that you can access on AWS, and there's various AMIs that you can use.
Yeah, so you're right there, almost. They're not virtual machines, but they're virtual machine images.
Oh, images, yeah. What's the difference between a virtual machine and an image? Isn't
an image is just a copy of an operating system, right? Remember what we downloaded the last time? The CentOS?
The CentOS, yeah.
That's just an image. And then the virtual machine was a virtual box, because that's how we used to run it. So yeah.
Oh, okay. But the image gives you access to the machine, right?
No, the image gives you, without the image, you're not going to have any Ubuntu, right? To work on.
Yes, sir.
So the machine image is the operating system image that you're using.
Oh, okay. Cool. Yeah, that's just all I got from what you said.
Yeah, as long as you can understand that AMIs are machine images and they're separate, and then you take those images and you run them on a virtual machine, which is EC2, right?
Mm-hmm.
That's all you need to know, because as a DevOps engineer, these are your bread and butter. So security tools, Bajo. Yeah, go ahead.
And so those images, are they going to help you set up the server? Let me understand something, Will. Because
Yeah.
I remember when you're trying to set up the Linux server, you didn't find the Red Hat.
Yeah, I didn't find Red Hat, but I found it later, right?
Yeah.
But yeah, that's what you use to set up your instance. So the Amazon Linux you see, that's a Red Hat operating system pretty much. But you know, Amazon, they take everything and they change it, just like, you know, Mac and all these big companies. But yeah, so your image is what you need. So, okay, think about this, right? Let me put it another way. When you're running Kubernetes, right? You'll be running Kubernetes on the same images, but you know the difference? The difference between the Kubernetes image and these regular images that we have is that they're going to have something we call kubelet. And that's essentially what's going to be able to run a Docker image, right? So let me put another example. When you have a machine, right? If I wanted a quick machine, your virtual image is essentially something that you've already packaged. Remember, you know, there were two images that we could use. We could use an ISO image on our virtual box, or we could use a virtual disk image. The one we had on CentOS, that was a virtual disk image because that was already ready. But the ISO image has to be converted to a virtual disk image. So what I'm telling you is all these AMIs that you see on AWS, you can use those ones that they already have, right, Bajo? The Ubuntu's and stuff. You can also create your own.
I get it.
Yes. And you can create your own. You know how you can create your own? I think I should go back to that concept real quick. So remember, this will probably help the class understand this concept better. So now, remember, I have this HTTP. You remember this instance? That already has an Apache already running on it, right?
Yeah.
Let's say, for example, next time, I want a system that already has Apache running on it, right? I don't want to run, what I'm saying essentially is, I don't want to run that user data again, right?
Yeah.
I just want a system that already has that user data already running for it. You get it?
Yeah.
Now I can come and say, okay, since I already have an instance here running that already has all those things installed, how about I just create an image off of this virtual machine, right?
Yeah.
So now if I create an image, where is it? If I create an image, what I'm doing is I'm creating an AMI, right? So the idea now will be when I'm done creating that AMI, if I created a virtual machine using that AMI, it should already have Ubuntu. Sorry, it should already have those installations, right?
Yeah.
So you start to see the idea why the AMI is so important. So you could pretty much create a pre-baked AMI, an AMI that already has the application running. And all I have to do is just run that application. Simple as that. Think about it. Isn't that cool? So you see, I could create a virtual image off of that. I'll just call it HTTPD. And you describe it, HTTPD installed or whatever. You know, I'll add a tag, type. I'll just call it HTTP. I always put a tag, guys, even if it's not important. HTTPD. So I want to create an image off of that. So now, my idea now is when that image is done, when I launch that instance, I should automatically have this running. Let me open that real quick. You see that? I should already have all of this already installed. So that's AMI, and that's how you use AMI. That's why, you know, I added the AMI into our lecture. You know, like I mentioned to you before, I only teach you what I know and what I've been using. And I've been a pretty successful engineer, if you will. So anything I mentioned in this class, I'm not just taking things from left and right, blah, 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 and just putting them together. If I mention anything in this class, know that's something that I use. Or that's something that I've come across pretty much. So I want you to keep that in mind. And, you know, if I use anything or I come across anything, I'll show you in the class. I might forget some, but trust me, the most important things that I use and I come across, I'll teach you in class. So the same things we're talking about, these same things we're doing right now, when you become a DevOps engineer on AWS, you do the same thing. So you might do it using API or using code, but you do the same thing. So keep that in mind. So anyway, so I hope AMI concept is a little bit clear.
Yeah, I mean, theoretically, I think we have an understanding what it does. We just need to go into that application phase, which is what the videos are for, and practice also.
Remember, practice. You have to, for every hour you do in class, I promise you do 2 to 3 hours at home. That is if you want to become a DevOps engineer. I mean, and why not? I mean, they pay good. There's so many jobs. You know, even now, I see have companies contacting me 4 or 5 times for the same job because I'm not responding pretty much. And they're sending emails upon emails. So many jobs, guys. Just learn this. Make sure you do a lot of practice. And you know what? The more practice you do, the more questions you always have, which is a good thing. So practice. Remember, I keep telling you, if you're just going to base off of this class and not practice, you know, sorry to say it, but you're wasting your time. You have to practice, do hands-on, go on AWS, play with it, do the same things I'm doing, and even do more. And if you do more and you have questions, you know, you come and say, oh, I tried to do this and this happened. That's how you learn. And you have me here. You know, when I was learning this, I didn't have anybody, but you have me here. So I want you to take advantage and make sure you learn this stuff. So you have questions to ask. You know, this is a big opportunity for you. I'm telling you, once you're done with this, you know, you easily be making 130 a year or more. So this is a big opportunity. So you should be taking it seriously. Anyways, let's go to security groups. So these are some of the basics of security groups. So your virtual firewall for EC2, right? It's like a virtual firewall. So remember, I did an inbound rule, but there's also an outbound rule. So you know, outbound means whatever is going outside of my EC2 instance. And inbound rule is whatever is coming into my EC2 instance, pretty much. That's how easy it is. Inbound, coming in. Outbound, going out traffic. You can have a max of 5 security groups into one instance, but I don't see why you should have up to 5 anyways. You know, I've never really had more than 2 security groups on one instance, on one load balancer or whatever. So you have up to 5, so you don't really need that, to be honest. You know, the max, like I said, I've used is 2. And, oops. And then you have, this is a link. If you wanted to study more about security groups, it's right here. Just follow it and just read whatever you can about security groups. And there's something else that I just wanted to mention. We don't have this set up, but I might set it up later for our company, but it's called a network ACL. It's pretty much the same as a security group. It's just the difference is at the subnet level. It's at the network level, which when I explain about VPC, you understand what the subnet is. So don't worry about that. And then this is a link to study a little bit more about, you know, network ACLs, but it's essentially what security groups are doing at the EC2 level. These guys are doing it at the subnet level. So we'll talk about, you know, VPC and subnet in our next class. That's a big topic, guys. So I want you to go practice this before next class, so you can have a foundation when we talk about VPC, because it's not an easy topic, but it's a very important topic. It's a foundation of where everything ties in at the end of the day. So Bajo, I know we talked about this, but let's go back in there so you could ask a question. So we just talked about security groups and basics about security groups. So let's see. Sign into my console. So let me just open security. Remember, with AWS, it's so easy. You can search anything here. So I'm so lazy. I don't want to have to go through. So I'm just going to search for security groups here. And so we have a few security groups. We have this. I know these ones were created by us. So let's go. Bajo, you had a question.
No, I don't think so. Carry on.
Yeah, but anyway, I'll just say this again. Remember, when we say outbound rules, you see this? Whenever you see this destination, 000, it means it's saying pretty much everywhere, anywhere. So what I'm saying essentially is this EC2 instance can be able to talk to anybody outside. And then when we go to inbound rules, remember inbound means coming in. Remember, I had to open 443 so I could be able to see my web page. So because me, when I put that web page in my browser, I'm coming in. So yeah, so I have to open 443 so I can come in and see that, access that browser. 22 is coming in, which means that I can SSH, I can log into that server. 8 is HTTP, so it's an insecure version. But most companies, they're gonna be converting. Remember, you know, I don't know if anybody remember this, but when I was creating the CloudFront, I redirected from HTTP to HTTPS. I can show that real quick. I redirected from HTTP to HTTPS. And that's essentially what I did there. What I did was, I was saying that instead of coming from an insecure, which is 80, I want you to redirect from 80 to 43, which is secure. So that's pretty much what that is. So remember, go watch the video again and it'll make a lot of sense, especially if you practice. Let me see what time it is. I feel like people are already getting tired. So let's see. I'm going to talk just a little bit about this database. And then next class, we're going to talk about the permissions, guys. Alpha, I know I promise we're going to talk about permissions, but I don't want to keep us here. Remember, permissions the next after this. We'll talk about permissions and then we'll talk about networking, like VPC, subnets, and how everything ties together. And how we can build our own VPCs, our own subnets, and be able to store things like this inside, and be able to isolate it. So anyways, any question? So RDS, remember, I know some of you have heard, some of you may have not, but you've heard about guys doing DBA, right? Yep. DBAs and all that stuff. So what DBAs are essentially doing is they're managing databases pretty much, right? They're managing databases. So most DBAs, as you see, these are some types of databases that you have. And if anyone was wondering what the database is, a database, I'm going to add more. Let me add a link to RDSs. But database is essentially, when you have things, applications need to have somewhere that they can store and retrieve data on the fly, right? And this case is not going to be S3, right? You need something because the S3, user management is some type of way, you can't really go in there and create users. You can't really secure it with an access. You can't store data in you can store in a particular format, but the database is just different, right? Because you can hold connections to your databases, you can access. So a database is essentially where you store your information. So for example, Walmart.com. When Walmart.com wants to go back to a server, when you go on Walmart.com and you say you shop online, and let's say you buy a bed or a t-shirt, pretty much. But I want to say something a little bit more, limited. Let's just say you go to Walmart and there's 10 TVs, right? You buy one TV online on Walmart. Walmart system now have to go back to what we call inventory, and they have to subtract. Let's say we had 10 tables left, 10 TVs. When you buy one TV, Walmart needs somewhere that you can go check to see, do we have any TV left? Yes, let me subtract one TV so we only have one left. And then when the customer checks out, if the customer cancels their order, I'm going to send back that one order and add it back to the database. So you need something like that where you can quickly make changes, retrieve data, add data, and make changes like that. And as you can tell, S3 is not built for that, right? So that's what the database is. So all these DBAs you see taking classes, they're managing all that data. When it comes to managing the data, I used to be a DBA before, so I know a little bit about these databases. But if you wanted to manage data, so you need people managing your database pretty much for a big company, right? You need people managing your database because why? Sometimes databases can get slow, so you need to optimize it. Not only that, but sometimes you need to give users access to a database, manage users and stuff. You also need a backup of your database. So if your database goes down, you don't want to lose all your data, right? Customer information. So your database essentially stores everything. Customer information, orders, customer data, in fact, everything that you can think of. What an application uses, formats. When you go into an application, when you see an application code, there's going to be formats in the code where it takes in input from a user. It takes in credit card information and all that stuff, right? You store that in a database. So you have people managing that. So now what Amazon is doing, so now instead of having DBAs, right, that are building the database, doing replication, making changes, maintenance and all that stuff, Amazon said, no, we don't need, how about we manage that database for you? And you pay us for, whatever database you use. And you don't have to worry about patching, backup, and all that stuff, right? Isn't that so cool? So now you don't have to worry about, I need a DBA. And I'll be paying a DBA maybe 80,000 or 100, even 120 a year. No, we don't need that, right? And all that stuff. It simplifies your job for you. So now, so where does this fall? Is this software as a service? Is this platform as a service, or is this infrastructure as a service?
I think it's infrastructure as a service.
Okay, why?
Because if you have a database, typically if you were to host that database locally on your own, you would have to keep it like on a server, right? Maybe it's a little bit of both, because
it's a little bit above, exactly.
Yeah, because infrastructure as a service, but you also need someone to manage that infrastructure.
Platform.
So there's that platform as well. So
yes, the AWS platform. So this is platform as a service. So AWS offers that. And as you can see, the types, you have Aurora. This is basically what MySQL is. MySQL is Aurora, but it's Amazon's version of MySQL. You see, we have Postgres. I love Postgres, by the way. You know, I worked as a MySQL DBA for like a year. I worked as an Oracle for a little bit. And then SQL Server is one created by Microsoft. So we have SQL Server by Microsoft. We have Oracle by Oracle. We have MariaDB, which is open source, which so is pretty much created by no one. MySQL is also open source, but it's managed. And I didn't know AWS manages MariaDB now. That's interesting. Then we have Postgres, which is also a relational database. And we have Aurora. And there's one more thing I want to mention before we go forward. RDS means relational database. But there's another kind of database that is a non-relational database, right? Which is concept, which I want you to go read a little bit if you're curious. But Amazon also has some of that as well, non-relational databases. So essentially, for the big difference, if you're curious, between a relational database and a non-relational database is for a relational database like Aurora, Postgres, what you'll be used to, everything is structured. So you have everything structured, which means that if you put the wrong data in the wrong field, it's going to give you an error, right? If there's things called primary keys. So it's very, very controlling. But a non-relational database is the opposite. You can store data anyhow you want to store it, in any format. So it definitely has its advantages. And one of them is called DynamoDB. So just keep that in mind. If you have any questions about that, just do a little studying. And then you can ask me. I can talk all day about databases. But good thing is, as a DevOps, you just have to manage it at the top level. So just bringing it up, bringing it down, logging into it every now and then. I just never do that. But yeah, bringing it up, taking it down, managing it, and things like that. But you're not going to go in there and running SQL queries left and right. So I'll show you what it looks like. So remember, as a DBA, you have to, manage systems that have, like CentOS, and then you have to install the databases, right? As a database administrator. And then you have to be taking care of the versions, right? And the upgrade, if anything goes down, you have to fix it. You have to do things like high availability. But with Amazon RDS, you don't have to do none of that. That's why I tell you cloud is so popular. And you can see why cloud is here to stay. Because think about things like this. Now, me personally, I've been thinking about starting companies. When that time is right, guess what? I'll just use Amazon to create my system. Why? I don't have to buy a server. So server is already there. I don't have to find a DBA. I already have my RDS. I don't have to do all that. So I could just be my application and running AWS and have my company running without doing all this other complicated stuff. So you see how Amazon is making things easy?
Yeah.
So I think we should go a little bit into mine and just look at RDS a little bit before we end this class. So RDS, I just wanted to take a look. Remember, as a DBA, the most you can do is, I'm saying DBA now. As a DevOps engineer, the most you're going to do is to create the systems, create a database, which we're going to use code with Terraform. We'll create that database, bring it down, manage it, make sure it's this, create high availability, and just do the basic administrative stuff. You're not going to be a DBA. The application team, the developers will know how to operate the code so you can be able to access the database. And then the operations team will know how to bring up the systems. And then the database and the dev team, there's always going to be an analytics team or data team. And trust me, the data team will be doing all that DBA tasks for you. So this is an example. I wanted to create an Oracle database real quick. Bajo, you see, Oracle DBAs, this is essentially what they work on. But this is just, you as a DB, as a DevOps, it's just one of your tools. So let's say I wanted to create Oracle. It's as easy as doing this. Normally at work, I'll do it through code, which is why I decided that I'm going to add Terraform to this class, because I'm going to do it using code. I'm not going to use the UI. But once you use the UI, you understand how everything works. It's easier for you to put it in code pretty much. So anyways, so I want to create an Oracle real quick. Yeah, I want Amazon to manage it, RDS. I just want the basic, I want the enterprise edition, Oracle version. This is what some DBAs end up living in a week. This is what they're going to tell the company. I updated from Oracle 12c to Oracle this. That's basically what they did the whole week. But these are all the versions here I could choose. Seriously, a DBA will tell you I just updated from Oracle 12c to 19c. That took me a week. What? Yeah, so that's why cloud is the best. That's why if there's anything you take from this class, if you want to be in IT, is that I want to work in the cloud. Anyways, this is my identifier. I'm just going to call it Oracle database. So this is how you create a basic database. And then this is what, as a DBA, they will warn you, please don't share this. This is admin login. In fact, even you as a DBA, you're the only one that has access to this admin username, and the admin password, right? And they'll tell you in the company, man, it's like you hold the keys to the database pretty much. And they'll be acting like, they're kings. But this is what we're doing right here. So when I want to log into my Oracle, I'll log in using the same credentials. So, I know class is almost over, so let's do something fun. Let me do a database that, that I've worked with recently, and we could do it, and then you could see how we could log into the database and do stuff. So I think I should add that for next class. What do you think? Next class, we're going to log into the database and just see how it looks like, and that's it. And you see what DBAs work on a daily basis.
You're sleeping?
So there's 2 deliverables on my end for next class. Hopefully, so I'm just going to post in the group so I don't forget. So there is a demo with RDS or database, and then demo with what was the other thing I said I was going to demo with? Load balancers. Yep. I just posted in the chat. So class, I guess this is it. So I think that's been too much for AWS for today. So, but if you're able to make it this far, you've learned a lot. And this is knowledge, this is invaluable knowledge. And you have someone that you can always ask, when you have questions.